For my talk, I have a couple of takeaways for you this morning. First is that future technologies will also bring vulnerabilities. I think we've seen this time and time again. But the good news is we can use what we already know to defend the future. We don't need new tools to be invented to be successful. Let's get started. The past few years have certainly felt uniquely uncertain. The world seems as though it's getting rather chaotic. But in reality, the world has always been an uncertain place. There's geopolitical conflicts and global pandemics and natural disasters and wars and even the job market. All of these things are outside of our individual control. And our perceptions of these events are amplified through social media and gives it a unique feeling of instability. But we also have this concept called the real world. And this is the environment where technology exists. When we say something, works in the real world, we often mean that it's robust to the complexities of a given use case. The real world is often far more complex than people give it credit for. There's filled with edge and corner cases and a bunch of other unknowns that confound our technology deployments. The other thing fueling uncertainty is vibes. Our entire moment is fueled by vibes. Vibe coding, vibe analytics, vibe security, and pretty much vibe everything else. And what we seem to forget is that vibes are nothing more than feelings. And quite often, our feelings are wrong. That's great. We'll put up with that. They're often fueled by hopes and desires and biases. And it's not a great foundation for the future to be built on vibes. And of course, we have all of these predictions that are also based on vibes that fuel wild amounts of uncertainty. And it seems that the tech press seems to continue to run with these things because they get clicks. And in the current environment, we often reward people for being bold, not for being right, which seems to be the opposite of what we would want from predictions. And there's an old saying that says, never trust a prediction when the person's paycheck depends on it. And I think that that's pretty good advice. And this extends to people like influencers as well, and the press. They're trying to get our attention. These people are exploiting our intuitions about the future because a lot of these predictions may very well come true at some future date. And I think we kind of get the impression that that might happen. But what's happening with these predictions is they're closing that timeline. What we're seeing here is a lack of technological modesty. The technological modesty is a concept introduced by Paul Goodman in his 1969 article, Can Technology Be Humane? And all it really means is being realistic about a particular technology and its capabilities and not making up a bunch of things about things it can do in the future. And this is best expressed with an example that comes from Neil Postman's 1992 book, Technopoly. And today, there is wild speculation about the capabilities of generative AI. And generative AI remains massively overhyped, even today. And I think in 2025, people started to get a lot more realistic about what generative AI can and cannot do. However, I will warn that being overhyped doesn't mean useless. So if we feel that generative AI is overhyped and it's useless, we would not be setting ourselves up for success in the future, that's for sure. Another thing fueling uncertainty is the job market. Part of the predictions is we're told that we're a mere year or two away from being replaced by AI. I will tell you that this is nonsense. However, this impression remains. And even shortly after ChatGPT was launched, there was a very famous saying that kept being said over and over and again, and it consists of two sentences. AI won't replace people. People with AI will replace those without. And I think if we take a step back we realize that neither of these two sentences is true. So first of all, AI won't replace people. We know that's absolutely false. We have people, CEOs today, out there publicly claiming that they want to replace people with AI. So the moment the capabilities of the AI system are capable of taking people's jobs, they absolutely will. However, the second part of this statement is also wrong. I think we need to ask ourselves, as humans and as workers, what is our differentiator? What are we bringing to the table? Is it just the ability to ask AI questions, or are we bringing our own set of unique skills and perspectives to a task, to a job that makes us unique? I think that's our differentiator. But we are seeing impacts of AI on the workplace. In many cases, we're trading one set of productivity for another. It's kind of like a productivity shell game. So, increased productivity in one area is causing more work in another. And there's a lot of claims that companies are laying people off because of AI, and I think that sounds cool, but quite often that's cover for other reasons. We're also seeing that many generative AI projects are failing at enterprises. And this makes a lot of sense because there are many different reasons why generative AI projects may fail, right? First is choosing the wrong use case. You also have unrealistic expectations. There's failure to account for complexities, and there's also things like failure to account for cost. All of these things can have a negative impact on generative AI projects. So what does the future of technology really hold? I think one of the trends that we can see is that technology continues to get closer to us, more personal, more customized, worked into every aspect of our lives. If you remember when computers used to sit on people's desks, now they sit in people's pockets or on their wrists. There's also a push to build objects, right, to build devices that record every aspect of our day. So now they follow us around in a sort of surveillance friendship, recording every single thing we do, every single interaction, and generating insights and more data. Obviously, this becomes a privacy issue. But it can get even more close to us, and that is where implantable technologies happen. Right? That's the brain-computer interfaces, the things that go inside of our bodies. And this space is actually heating up. And I think we're moving so fast that we haven't stopped to think about these technologies' impact on us. Because as a technology gets closer, a few things happen. We tend to notice it less, we lose sight of any manifested dependencies, and we fail to recognize the vulnerabilities that it creates. Think about the vast sources of information that these particular devices create. A more invasive technology is going to make this problem even worse. It's going to generate more data that now needs to be protected. And of course, privacy and security have to be a fundamental aspect of these technologies for them to be safe. Another trend that is happening that will increase here in the future is embodied technologies. And these are technologies that learn from and interact in the real world. Think of things like robots and drones and self-driving cars. Now imagine moving errors, hallucinations, and the ability to manipulate these technologies into the real world. So now you have devices interacting with physical objects. This can be very dangerous. We're also becoming more and more comfortable with not understanding how the technology that we integrate into our daily lives works. We're moving to technologies with even less visibility. I mean, we should want to know how the technologies we use come to their conclusions. I mean, we need to be able to keep technologies in check. Another common thing that's happening is there's a massive amount of what's called AI slop being generated on a daily basis. If you've been on social media recently, you've seen a bunch of these technologies, the output of the technologies. But there has some real-world impacts here. It's quite possible that the errors and hallucinations of today become the ground truth for tomorrow. We've had instances where, like, OpenAI's Whisper has been hallucinating into people's medical records, creating a new ground truth. And future systems may actually learn from this hallucinated data. And the problem here is we don't know how big of a problem this actually is. It's something we are going to just find out in the future, which is something scary. Back in May of 2023, I wrote an article called "The Brave New World of Degraded Performance." And I called out this trend of developers outsourcing functional components of their applications to things like large language models. And it even came complete with a description of what would become known as vibe coding. The problem here is that in an attempt to make difficult things easy, sometimes we're making easy things difficult. And this creates sort of functional problems inside of applications, creating conditions where unknowns have become the new normal. When you replace functional components of your application with large language model calls, we have conditions where developers don't know what code is going to execute at runtime, because the code literally doesn't exist until the application is run and the function is called. You cannot perform code review on code that doesn't exist. You can't perform quality assurance on code that doesn't exist. And these systems often have conditions where small changes in input can equal large impacts on the output, and this is something we're still grappling with. This use of unknowns has created something we call blind execution of input. This is from a library called MindSQL. It's something we presented at Black Hat USA this year. In this example, there is a prompt that is being created based on user input. That prompt is then sent to a large language model, which then generates code sent back to the application, which is then executed by the application and run. So the Plotly code here doesn't exist on the screen. It doesn't exist till it runs. And if you are observant and you do code security, you may have noticed that this is exactly how you create a remote code execution vulnerability. Taking attacker input and executing it on the output. And you are correct. Of course, all of these new technologies, let's stop for a second. So in that previous example with that remote code execution flaw, whose system is that running on? Probably yours, because that was a library that was meant to be consumed by developers inside of their applications. Future technologies will also push security back on the user and the developer, which is why we as security professionals need to be more vigilant when our developers are adopting these technologies. I do think that generative AI and the current issues with generative AI are a great example of how future technologies will also be impacted. And the lessons that we learn from generative AI apply to future technologies as well. So the first thing to understand here is that generative AI actually increases the attack surface of your applications. It also doesn't care whether you're an attacker or a defender. So whether you are writing a generative AI-based application that books travel for people, vulnerabilities don't care. Or whether you have this brand new, shiny, agentic AI security application, the vulnerabilities are the same. And it increases the attack surface in two meaningful ways. So first of all, through its inclusion, how people implement it in the application. And secondly, through enabling poor security practices, or I should say encouraging poor security practices. For example, we have people building brand new high-value targets where they're mixing internal, external, sensitive, and non-sensitive data together to create a single data set in order to attach AI and get insights out of it. This makes breaches far more impactful, and also it's something we've known from the history of information security that are poor practices that we shouldn't do. You know, With generative AI, once an attacker can get data into your system, you can no longer trust the output. And that is one of the fundamental takeaways here. People are also using generative AI as a sort of universal computation engine, using it as an oracle. And this is a system with features and functionality that no developer programmed into them. And this is important for design. When we design these systems, we need to account for this functionality. It may help to think about generative AI as yet another operating system we need to protect. So just because an attacker's input doesn't make it into a Python exec statement doesn't mean that it isn't unsafe. Something we need to think about. This system that no developer programmed features and functionality into also has a vast space of undocumented protocols. So what do I mean? Like every example on the screen right now, they all say the same thing. It's just different ways of representing input. You do not, if you give a generative AI-based system base64 input, it is going to go ahead and decode that input. It'll recognize it and decode it. There's no developer program that function into there. And this is a good thing for attackers. There's more space, more opportunities to get their input into the system, which means traditional input validation might not get us as much as we think. Speaking of application manipulation, how many people here have heard of prompt injection? Everybody's shy. So prompt injection is one of the biggest issues in large language model applications. And it's true that prompt injection and SQL injection, from a technical perspective, share the same type of problem space. It's the inability of the system to differentiate the command space from the data space. However, with generative AI systems, in practical realities as you attack a system, prompt injection looks more like social engineering applications than it does SQL injection. There's no defined specific set of characters that will give you the output. And if you remember that unlimited number of undocumented protocols, it becomes a large space for attackers. And developers are not accustomed to having their applications talked into doing things that they didn't intend. And I talked very briefly about blind execution of input. In reality, a lot of these systems are taking user input or application output, combining them together with some context, making a request to an LLM, and then executing the output. That's just how some of these tools work. Even some of the agentic frameworks, this is how they work. They're code execution frameworks. And it's kind of surreal to see people praising organizations in the United States like CISA for pushing memory-safe languages to avoid things like remote code execution, while on the flip side, praising organizations for building something that resembles remote code execution as a service. When you connect generative AI-based systems together and agents, for example, right, manipulations and failures and hallucinations, these things will cascade through a system. In the words of Demis Hassabis, they compound like interest. So as we are looking at the design of our applications, we need to take this into account to make sure they're resilient. Of course, another thing that's happened recently is that chatbots, for example, are only so useful. So people have started to empower them to do things, to take actions. Elevated permissions, elevated actions, the ability to call tools. These are all things that we're giving these systems the ability to do. So now you have a system that's built on easily manipulable components that are connected to some very sensitive systems. Least privilege becomes most privilege, and it's most privileged by default. This is a challenge for security professionals. Another trend we're seeing is that AI is being pushed all the way down. It's in every aspect, deep in every application. It's in our operating systems. It's in our web browsers. It's in our keyboards. Being pushed so deeply that it violates the general security properties of our systems. And this is to say nothing about what it does for privacy. But if you think about application isolation or something like same origin in the browser, these components have the ability to reach across those. And part of the problem here is that many of these tools are being launched by companies very deeply into systems without a use case. They're hoping that we, the users, find the use case for these particular applications. Now, I'm not talking about using ChatGPT or Claude or even building LLM-based applications. I'm talking about things like Microsoft's Recall or OpenAI's Operator or Claude Computer Use or Comet Browser. These are just some examples. But it means that the things we've counted on to be relatively secure in the past now have a new attack surface. And for anybody thinking about experimenting with any of these tools, please do them in a virtual machine. Do not use your native system. Otherwise, you will find that you may have things deleted or exposed that you didn't expect. At Black Hat USA this year, we did research across a bunch of different developer productivity tool suites. These are things that operate in the build environment, do code reviews, some of them even perform security tasks. The takeaways here were that we found vulnerabilities in every single one we looked at. These vulnerabilities are everywhere. And we kind of compiled these into some categories, themes, and observations across all of them. And if you've noticed that these aren't brand new things, that they're old things that we've known about, things from security's past, these things are now coming back to haunt us. So with all of these challenges, with future technologies coming along, and of course, current technologies we have like generative AI, what does defending the future even look like? Well, I say that it depends on two things: the technology element and the human element. Let's start with the technology element. How many people here have heard of the story of AlphaGo beating Lee Sedol at the game of Go? A couple people, okay. It was a very big accomplishment for Google DeepMind. Got lots of press, lots of heralding of the future of technology. But how many people have heard of the work on adversarial policy attacks? Probably nobody, unless you are just super geeky and follow a lot of academic research. The problem here is that even an average Go player today can beat these superhuman Go AIs through adversarial policy attacks. And this is sort of an indicator of what might exist for us in the future. So we may be stuck with vulnerabilities that there's no fix for in technology that we've deployed widely in our environments. And I think we're getting a bit of this with prompt injection today. We're getting a bit of a taste of this challenge. And I will even go so far as to say that AGI will be vulnerable too. We don't yet know what form AGI will take. I've said publicly that I don't think it will be built from large language models. I think we need new innovation to get to AGI. But regardless, we may be able to fix the reliability issues with these systems, but the manipulation issues may remain. And there's a group of people called AI doomers who think that AI is going to destroy humanity. And one of their biggest talking points is the ability of AI to manipulate humans. And that is certainly correct. But one of the things they leave out of the conversation is the ease at the ability of us to manipulate AI. There may be something about generalizing to the real world that makes systems vulnerable. We just don't know yet. So we may have these systems that are capable of human-level performance on a wide variety of tasks, but can be easily manipulated. And this would be a world that we're stuck with. So how do we do this? How do we plan for a future where we may be building vulnerabilities into applications, and we may have an unknown number of these vulnerabilities that we may be stuck with? It sounds very bad until you realize we already know how to do this through secure design and architecture. This is how we protect from unknowns today. We do this every single day. So proper analysis of threats and a robust implementation from attacks. And oddly enough, this is a lesson that we seem to learn over and over again. Every time a new emerging technology comes along, this lesson gets relearned. These core security fundamentals remain relevant no matter what the emerging technology is. If you launch a system that can do something, it will do something. We want systems that we build to stay in scope, to be properly isolated, to protect our sensitive data from manipulations and malicious actions and information disclosure. The secret here is to assume that your application can spin off the rails, assume it can be attacked, assume it can be compromised, and then build out from there. Your applications are going to be far more robust. And today, we see countless people focused on trying to identify and detect prompt injection so that they can protect against it. And that is really not the right approach. We should assume that the generative AI-based applications that we're building are vulnerable to prompt injection and design them properly to make sure that the damage is isolated. Back in May of 2023, I came up with a simple approach I call RRT, refrain, restrict, and trap. 3 simple steps for developers to be able to protect their applications from generative AI-based attacks. And even today, with all of the new guidance coming along, these 3 simple steps are pretty effective for people implementing these applications. One of the things we seem to forget is that complexity is the enemy of security. This is a very old saying in information security. And this is true in reality, but false in perception. Security professionals secretly love complexity. We think it's elegant. And the problem is that when we increase the complexity, especially in security tasks, it means people are less likely to adopt them. So we need to start thinking simply and making recommendations that are simple. All technology risks, including AI risks, are use case dependent. So if we use AI as an example, an AI model does nothing on its own. It needs to be put in an application and used for a use case, and that is where the risk starts to manifest itself. And if we think about that, if we think about taking technology, putting it in an application, and putting it in a use case, another secret here is that AI security is just mostly application and product security. The problem is, if you don't have these programs in place at your organization, then you are going to amplify your vulnerabilities when it comes to generative AI. You have to build solid foundations and build out from there. I mean, there are people trying to overcomplicate AI security. I see it every day. There's new recommendations coming out. You have threat modeling guidance that's like 64 pages long. We as security professionals are not doing ourselves any favors by making these things more complex. And in reality, we love to talk about AI security. We talk about it as a topic. But what are we really doing? I think what we really mean is securing our applications from the effects of AI. Because the AI component is just connecting things together. It's just a controller. The real impact happens on the systems, on the tools that it calls, on the outputs. And maybe it's easier to think about protecting your applications from AI. And that's another thing that you can kind of think about. You have to understand the environment in which these applications are deployed and the potential follow-on effects. Another thing that doesn't get talked about too much in the security space is safety. And I really think that safety, especially as we look at where technologies are headed, closer to us, possibly implanted, embodied in the real world, safety takes on a whole new meaning here, right? And I really feel that we need a new sort of definition for technological safety because it's kind of been co-opted, and I think what we really mean when we talk about technologies is we mean safe to use. Is this technology safe to use? I created something when there's a lot of talk about personal AI assistants. I said, what does safety really even mean in this context? And I came up with something called SPAR, secure, private, aligned, and reliable. So resilient to purposeful attacks, respects the privacy of users, aligned with the objectives of the user, and reliable to a reasonable degree. And I think that this is really a solid foundation. And secondly, it puts security as a fundamental part of safety. And I think that that definition will continue to expand and include security professionals in the future. So speaking of security professionals, let's talk about the human element. I have some good news for you, or I hope it's good news, unless you're somebody who just doesn't like your job, then I have bad news. But humans will continue to play a role in the future of cybersecurity. AI and all the other technologies are merely tools in our toolkit. Tools to be wielded by us, defined by us, and even checked by us. But we need to be vigilant. There's a lot of talk about human augmentation, either through the use of AI tools or even implanted technologies. But augmentation increases the human attack surface and brings vulnerabilities. Each new system opens the door for attacks. Let's imagine a brain-computer interface that we install in our bodies and allows us to have access to additional computation, additional memory, all of these other things. Here's a question for you. How do you ever know if a thought that you have is actually your thought? And an even more dystopian thing to think about is imagine having advertisements implanted in your memories. And if you think that's too dystopian to actually happen, just remember that one person's dystopia is another person's business plan. That's why we need to be vigilant. But even with the systems we have today, without this sort of brain-computer interface, generalized AI, like generative AI, isn't just impacting the systems we're building, it's impacting the humans as well. The human mind seeks shortcuts. We naturally do this. It's called cognitive offloading. We will offload tasks to tools we have. The problem here is that cognitive offloading also creates cognitive illusions and cognitive atrophy, which leads to a host of negative effects. I created a framework of 6 personas in which people use these tools, as well as a list of negative impacts from them. I don't have time to go into all of them, but I've written about them on my blog at length. And just a couple notes about cognitive atrophy. The seeking of shortcuts not only affects our skills, because I think we've kind of seen this talk about skills atrophy and a few other things, but it affects our critical thinking abilities as well. And we're seeing this not just in development, but in security operations centers where people no longer know how to do an investigation without tools. I mean, that's a problem. And there are even some people who have taken this so far that they won't do anything in life, but whether it be work or personal, without contacting ChatGPT first. And this can be a problem because we can't keep systems in check if we lose our competencies to do so. I mean, human in the loop becomes pointless if we don't have the skills to know whether the system is malfunctioning or not. We just have to take the output and actions as correct all of the time. This does not set us up for success. So what can we do when we want to use AI systems, but also protect our skills? Well, first of all, we need to have some red lines. There needs to be some things that we want to protect, that we're unwilling, some lines we're not willing to cross for some perceived capability. We also have to understand that there are trade-offs here, right? And these trade-offs might not be obvious from the beginning. I like this concept of a cognitive firewall because firewalls are something that you can choose to allow or deny. And you can also get granular with the things that you want to do. The point here is you have your red lines, the things you want to deny. And then for things that you want to allow and you want to maintain your skills, you add purposeful interventions. So say, for example, you wanted to protect your Python coding ability, but you love using AI coding assistants. At periodic intervals, you would stop and you would do the problem yourself and you would struggle through it, and that would keep some of those skills. Now, there's a warning here because, remember I mentioned humans are technically cognitively lazy. We look for the shortest path. So this takes work, and sometimes a lot of work, which is why this has to be important to you. And another thing to think about are bubbles, like filter bubbles. It's easy to get caught in bubbles, and a lot of social media platforms have algorithms that trap us in bubbles. And bubbles lead to surprises. That's not fun. So ask the right questions and maintain perspective. This is the best way to stay grounded in reality. Another thing to consider here is that the future may be less aligned to very specific skills and more aligned with our attributes. And what I mean by that are attributes like curiosity, adaptability, objectivity. I've been doing cybersecurity for a long time, and I feel it's not my job to love or hate any particular technology. My job is to allow the people I work with to deploy the technology that they want to in as secure and a robust way as possible. And you don't get that way by being all in. If you are all in on AI all the time, you will miss simple things and obvious solutions. And that's really where we should be. I have a couple of closing thoughts. One, going back to the good news, security professionals will be even more important than ever in the future. I kind of mentioned safety as one of those examples. And it's really time for us to step up and recognize our responsibility. Throughout this presentation, you've seen the important role that security professionals play in the future. Security is a fundamental component of safety for the next generation of emerging technologies. Another thing that we know for certain that the future is going to bring is change. That is, change will happen quickly and often at more regular intervals. So we need to be flexible and adapt. Innovations have an odd way of snapping into place, so let's flex our attributes and stay ahead. Of course, the key to being successful with any technology is selective usage and not blanket usage. So be mindful, use technologies for what it's best used for, and use other technologies where something might be a better thing. And that way we won't raise the attack surface unnecessarily. Evaluate your trade-offs. New technologies are all about trade-offs. It's very rare that you get something for nothing, or even cheaply for that matter. So make sure that what you get is worth what you're losing, and understand that what you lose isn't immediately obvious.